India and Pakistan have nuclear weapons now. The situation has diffused for now. Most of the world knew about this situation and watched and worried. But very few people knew of an event that took place over the Mediterranean on June 6th of 2002 that could have had a serious bearing on the outcome. The United States early warning satellites detected a flash that indicated an energy release comparable to Hiroshima atom bomb. We see about 30 such bursts every year. But this one was one of the largest we've ever seen. The event was caused by the impact of a small asteroid, maybe 5 to 10 meters in diameter, 5 to 10 yards across. So 10 yards, that's sort of the size of this building. The impact of that thing, 5 to 10 meters in diameter, on the Earth's atmosphere. Had you been situated on a boat directly underneath, the intensely bright flash would have been followed by a shock wave that would rattle the entire ship and maybe cause minor damage. So this meteor blew up in the sky and nothing ever reached the ground. A real small meteor. The event this June, however, the event of this June received little or no notice as far as we can tell. But if it had occurred at the same latitude just a few hours earlier, the effect would have been very different. You know, the Earth is rotating. And if this thing had happened earlier, it would not have been the Mediterranean where it landed, but India. That bright flash, it says here, imagine a bright flash accompanied by a damaging shock wave had occurred over India or Pakistan. To our knowledge, neither of those nations had the sophisticated sensors that can determine the difference between a near-Earth asteroid impact and a nuclear detonation. And you know, if you're poised for a thermonuclear war, you don't have any time. If there's a bright flash that happens, let's say, right over Delhi, you're not going to wait half an hour to find out what it was, because an intercontinental ballistic missile takes a few minutes to get to its destination. So you have to respond within a few minutes. And every country that has nuclear weapons is always poised for a very fast alert. You know, an extremely rapid scrambling to launch your weapons if you detect what you think is an atom bomb that's gone off on your territory. The resulting panic in the nuclear-armed and hair-triggered opposing forces could have been the spark that ignited a nuclear horror. So that's another thing that could happen. So sleep well tonight. It's a really serious danger or not. I mean, okay. You know, we can weave horror stories, but is this really something you want to worry about? What are the chances that something like this is going to happen? That previous graph I showed showing all the asteroids in Earth-crossing orbits. I don't know, there were 10 of them maybe listed on that graph. If there were only 10 of these things filling all this enormous immensity of space, that's not much of a problem. The question is, how many are there? How many asteroids are there which have orbits that cross the Earth? That's hard to know, because the asteroid doesn't have to be very big to be dangerous. I mentioned that those asteroids that I showed pictures of were roughly the size of Manhattan. That's tiny on an astronomical scale. A really big asteroid is, you know, hundreds, thousands of miles across. But that is such a if one of those things landed, it would be a truly planet-wide catastrophe. But even something like Meteor Crater or this flash that might have ignited a nuclear war, that was produced by something the size of this building. It is almost impossible to detect something the size of this building out in the asteroid belt. The asteroid belt is a long way away, and it's very hard to find these asteroids. So if I wanted to do a search to really find out if we're in danger, I would need a huge telescope looking for a long time, very far away. And that's hard to do. Nevertheless, there are a bunch of programs that have ramped up looking for Earth-crossing asteroids. Ever since people started to take this seriously, people have done really careful searches for how many asteroids in Earth-crossing orbits are there. And here's the result of one of these searches. This is known Earth-crossing asteroids. This is how many asteroids we know of in Earth-crossing orbits, 1980, 1982, 1990, 2000, 2002, 4, 2006. How many there are? 0, 500, 1,000, boom, boom, boom. This blue line is all asteroids in orbits that intersect our own, and these are the big ones. And big means larger than 1 kilometer across. So let's take a big one, larger than 1 kilometer across. A kilometer is sort of roughly half a mile. So if something a half a mile across landed, it would be a serious catastrophe. And even something a lot smaller would be bad. So notice that from, back in the past, 1980s, we knew of very few of these things, and all of a sudden we knew of more and more and more. What happened around 1998? Why is it that ever since then the number of asteroids has dramatically increased? The answer is that starting in the late 1990s, people really started looking carefully for these things. It's not like there are more than there used to be, it's that we know of them now and we haven't before. Well, I find this graph a little bit terrifying, because how many are there going to be next year? Presumably, eventually, we're going to be able to find all of them. But we haven't found all of them yet. People keep building bigger telescopes. They keep using more and more sensitive detectors. So I think the only thing we know this graph is telling us is we don't know how many of these killer asteroids there are, but there could be a lot. All right? Now let's fold that into the issue, which is there's a lot of empty space. I mean, here we have just a little bit less than, as of 2006, there's a little bit less than 1,000 asteroids that would be really horrible if they landed. And 3,500 of ones that would cause a pretty serious problem if they hit us. But that's 3,500 spread over a huge volume of space. So my analogy of traffic down the road, that's not a good analogy. If I want to think in terms of this analogy of traffic down the road, I would think of driving out in the middle of New Mexico, let us say, on some road where the nearest other car is 20 miles away. Well, so we got to fold in how many asteroids there are, with how much space they're filling, and how rapidly they're moving, and try to estimate what are the chances of a collision. And people have done that, and let me just show you one of those estimations. This is sort of a complicated graph. Let's spend a minute just looking at it. This axis here is how big is the asteroid we're talking about. And this axis here is how often the collisions happen. This is a pretty small asteroid, 10 meters across, 10 yards across. No, I'm sorry. This is how big the asteroid is, 1 meter across. 1 meter is that big. There's lots of asteroids that are small. There are lots of asteroids this big. Here's 10 meters across, 10 yards across, 100, 1,000, 1 kilometer across, that's around half a mile. 10 kilometers across, that's sort of the size of Staten Island or something like that. Down here is the size of the crater that it's going to dig. A 1 meter asteroid produces roughly a 10 meter crater. A 10 meter asteroid produces a 100 meter crater. The crater is around 10 times bigger than the asteroid. So here's a hole in the ground 1 kilometer across, blah, 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 things like that. Now, here is the really terrifying. Equivalent size of a bomb. How much energy is released when this thing lands? If a 1 meter asteroid lands going at the speeds we calculate from their orbits, it would be it would release as much energy as a 10,000-ton bomb. 1 megaton, well, a hydrogen bomb, a thermonuclear weapon is maybe 1 megaton. So your standard garden variety hydrogen bomb that's never been used in wartime is produced by something that's, well, around the size of this building hitting the Earth. A 100 megaton bomb. I am